In this lesson, I want to discuss the hormonal regulation of our glomerular filtration rates, the rate in which we're going to produce filtrate in the Bowman's capsule through the glomerulus, and then we'll go on to refine this. But you have to understand that this guy is all driven by pressure. Kidneys are driven by pressure, pushing from the bloodstream. It doesn't have, it's not a very highly metabolic organ. So to do this, if our blood flow gets too low, there's going to be absolutely no filtrate production. Now, we already know that we have a structure in our kidneys known as the glomerulus. Then we have a Bowman's capsule, and we'll narrow him down to the distal convoluted, the proximal convoluted tubule. And then we go on a course with the nephric loop, etc. Now, I'm not going to discuss all the structures of the nephric loop. What I'm more interested in here, I'm going to bring in our glomerular capillaries, and I'm going to do a very simple sketch of it. Now, what I want to make sure I show you guys is that the afferent arteriole is much bigger than the efferent. So let me put an arrow in and have A for afferent, and then an arrow going out, and E for efferent. The afferent arteriole is much larger than the efferent arteriole, the one that exits. So blood is coming into the afferent arteriole, and if this blood is not coming in with enough force, we are going to begin releasing the renin-angiotensin mechanism. And the renin-angiotensin mechanism, as we already know very well, the renin-angiotensin-aldosterone mechanism is released by the kidneys. Renin is released when blood pressure drops, and this blood pressure, note we made a special thing that the afferent arteriole being bigger, as blood is coming in, it can come in much easier to create a lot of pressure. But the efferent arteriole is constricted to kind of create a backflow. Like we want to make a traffic jam of blood in the glomerulus. But if it's still low, if our GFR, glomerular filtration rate, drops down, we can increase this through some hormonal regulation. And this takes a while to do. One thing we're going to release is angiotensin 2. Angiotensin 2 activation. So I'm going to write angiotensin 2. Angiotensin 2 is going to constrict the efferent arteriole. And this is going to further create that backup of blood. It's going to back up, and we're going to increase GFR. So we could see the GFR, the glomerular filtration rate, will increase in that way. Now, we also know that renin angiotensin mechanism, angiotensin 2, will also trigger the release of antidiuretic hormone, and ADH will make us thirsty. This increases our water intake. This increases blood volume, and thus increases blood pressure. Now, secondly, what's going to happen, and after angiotensin 2, we'll set up the cascade to release, of course, our good friend aldosterone. Now, aldosterone, as we know, will also increase blood pressure by retaining sodium, and this sodium will cause an increase in blood pressure, so BP will increase, and this will again increase the amount of fluid, increasing the glomerular filtration rate. So I hope this very simplistic look will help you to understand hormonal regulation of the glomerular filtration rate, or GFR, and how we can increase this rate of filtration production. Then we will further go on to refine that in our kidneys and produce urine. So I hope you find this video useful, and this concludes my video on hormonal regulation of glomerular filtration rate. Thank you.